Hello friends, I hope all of you are doing well and staying happy and healthy. I sincerely pray to the God that all your loved ones also stay happy and healthy so as to see you achieve success and you making them proud one day. So this video is the first part of the series in which we'll be covering the Dagger2 framework in Android. I'll be making short and concise videos and would cover each topic in detail for your better understanding. We'll be seeing how dependency injection technique works and how it is implemented in Android using the Dagger2 technique. Before we move forward, let us be aware of the three terms that we would be using frequently in this topic. Those three terms are: what is a dependency, what is a dependency consumer, and what is a dependency provider. So as you can see here in the left, class car requires an object of class engine for the proper functioning of this particular class. So to start a car, we need an engine to start. So engine is a dependency and class car is the dependency consumer. It consumes the dependency for the proper functioning of that particular class. Similarly, class engine, as you can see on my right, is the dependency provider. It provides the dependency. Now, since we are aware of these three terms, let us first understand the basic principle behind dependency injection, the underlying principle on which this whole dependency injection technique works. The underlying principle that we'll not talk about is the inversion of control principle. So it is a very well-known principle in the software field, and it states that any dependency that a particular class needs to perform its actions should not be created inside that class. Instead, it should be fetched from an external entity or a framework or maybe a dependency injection technique that we'll be implementing in our software. So it is a design principle that changes the way how components and entities interact with each other. It results in loose coupling among classes. Now we'll see, with the help of a simple code example, what exactly inversion of control principle is and how does it helps us in developing scalable applications. Let's start with the code. So I'll be taking the same example that we have just discussed of car and engine. So here is the class car and it contains the object of engine class as its member variable. As you can see here that we have declared and initialized the engine object. Now we have a public method start car, which when invoked would invoke the start engine method of the engine class. Similarly, we have the engine class and it just contains a public method start engine and it's just print down that the engine is started. To run this whole process, we have a prepare vehicle class and it contains the main method. We create a car object and we call the car.start car. So let us run this. So we see that the engine is started. So if we can see in the car class, as we already discussed, that this engine object is a dependency of class car. But we are violating the IOC principle here. The IOC principle states that the dependency should not be created inside that class. But here we are actually creating the object of the dependency inside the dependency consumer class. So one can ask, what is the problem here? See, the problem here is, now suppose in the future we have to modify the engine class. Suppose we have to add a special field, how much is the capacity of the engine. So we have to add var cc of integer type. So we have changed the engine class. We have added a property to it which is the power of the engine, which is measured in terms of cc. Now this change has affected the car class also. Because of a change in engine object, we have to change the code of class car, which should not be the case. So this is the problem which IOC solves. Since we have created this dependency, we are bound to change the code of class car just because the code of class engine is touched. Question now is, how do we solve this problem using IOC? Now since we have added a new field cc in the engine class, the code of class car is not compiling because we have not provided the required value here. One solution to this problem is Let us remove this creation, which IOC says do not create the dependency inside the dependency consumer class. Let's get it through the constructor of this particular class. And in the prepare vehicle class, let us create an object of engine with say 1000 cc and pass it in the car class. Let us now run this. So yes, our engine is started. So what is the learning here? The learning here is we applied the IOC principle, we removed the instantiation of the dependency from the dependency consumer class. Instead, we have fetched it via the constructor of that particular class. So the dependency is initialized somewhere else. We are just passing the dependency and it is getting the work done. Now suppose in the future, we need to add one more field. Say engine is of petrol type. Now we have added a new field. We don't need to do any change in this class car because we are doing every change here. So we just need to pass a boolean variable here. So our car is of petrol type. We have just changed here and there is no need to change in the dependency consumer class. If we run the prepare vehicle class, it would run fine. So this is a simple demonstration of IOC principle. We have to remove the instantiation of the dependency from the dependency consumer class. We have to procure it from somewhere else. May it be from the system, may it be from the dependency injection technique, but it should not be instantiated within the dependency consumer class. We are now completely aware of the IOC principle on which dependency injection technique is based upon. So what is dependency injection? What is DI? DI is a software design pattern which we use to achieve the IOC principle. DI enhances loose coupling between various classes. The benefits of DI is obviously the coupling thing. It reduces the tight coupling. It enhances testability and it helps us create scalable softwares. Since our basic concepts are now very clear and strong, we'll now come to our main topic, which is Dagger2. So Dagger2 is an open source DI framework developed by Google primarily for Java and Android. So the key features of Dagger2 are it generates the required code at the compile time so that all the problems, all the issues are detected at the compile time only and no runtime issues happen in the code while running. It is annotation based framework. It provides the scoping feature. Scoping feature here means it manages the life cycle of the objects that are created by the Dagger2 itself. It enhances the testability of the software, and yes, we've already discussed it helps us in building scalable applications. So this brings us to an end of this tutorial. In the next tutorial, we'll be seeing how Dagger2 is actually implemented in an Android app. If you really like the content, then please do like and subscribe. I thank you for your time and patience.